Hello and welcome to another math lesson with Mr. Elison. We're happy to have you here today. If you'll remember from last time, we were talking about volume of different solids, and we specifically investigated a cylinder. Well, today we want to take that another step forward and talk about a cone and see how those two relate. These ideas of volume are in our geometry strand in this state core, standard 8.G.9, volume of solids. And so we want to talk about those today. As we get going on there, we've got some software here we're using to look at a cone and a cylinder, and we want to be able to compare those two and see how they are. Now, from last time with the cylinder, we found out its volume ended up being pi times the radius squared times height. The radius squared was just the base of that cylinder times its height. So we have some geometry software here. We're looking at a cone and a cylinder, and we want to just investigate how that all is going to work. And what I've done is created both of them to be the same dimensions. They're the same size around, they're the same radius, same circumference, and they're also the same height. As I put the cone inside the cylinder, you'll see that it looks like it's going to hold less. Maybe the question of the day might be, how much less? So we'll investigate that here. I'm going to end up filling the cone. Well, you'll see it turn blue and that'll fill it, and then as I do that, we're going to empty its contents into the cylinder, and you're going to see what happens, and we'll see how much less it holds. And that's the idea here, and I can change the size. They're relatively based the same. So here we go. Let's put the blue in there. We start emptying those contents, and you'll notice that filled the cylinder about a third of the way. So it looks like it's going to take 3 cones to fill that cylinder. That's an interesting concept. That'll help us understand its formula a little bit. And as I change the dimensions of the cylinder and the cone, it's not going to change that idea whatsoever. Here's a completely different size, but again, the radius is the same, the distance around them is the same, the heights are the same, and as I fill the cone and I empty those contents, again, we end up with a third. And so that's what we want to do. And so that makes it easy to understand that, hey, whatever that volume of that cylinder was, the cone is just going to be divided by 3, because it's going to take 3 of those to make that happen. So that's a pretty neat thing to see right there. That helps us understand how that cone relates. No wonder when I buy a drink, my favorite Coke at the store, that they put it in a cylinder. I get 3 times more that way. It does make me wonder, however, when I buy a snow cone, am I getting my money's worth? Until next time, have a good day. See ya.